Hello my dear students, welcome to another episode of Blast from the Past. Now we discuss JEE Advanced Question 2020 from Binomial Theorem. Read the question. For non-negative integers s and r, they give SR. It is nothing but simple definition of NCR. NCR equal to what? N factorial by R factorial into N minus R factorial. They give SC, SR is S factorial by R factorial into S minus R factorial when R less than or equal to S, otherwise 0. This the definition of NCR. Here there is N plus P CP. This MCI. This term become N plus ICP and so on. This term for just give the definition of NCR. They give two functions. This is one of the multiple choice question, more than one correct answer. One function in terms of G, another in terms of F. Option they give in terms of G. So you first evaluate F of M and P. After evaluate this, find the value of this, substitute here. Then you simply get what is the function G. That's a simple function. From G of Mn, we check option one by one. That's the method, that's the technique we used. So I first simplify F of M and P. F of M and P. See. F of M and P is equal to sigma I is equal to 0 to P MCI into N plus I CP into N plus P C P minus I. We apply the result NCR. I give in first time, which is equal to sigma I is equal to 0 to P M factorial by I factorial into M minus I factorial into this term N plus I factorial by P factorial into N plus I minus P factorial. This term N plus P factorial by P minus I factorial into this minus this, N minus R, P are cancelled, it become N plus I factorial. Then what happened? These two terms are cancelled. N plus I factorial, N plus I factorial are cancelled. From the remaining terms, we make an arrangement. From the remaining terms, I make an arrangement. I just multiply N factorial on numerator and N factorial on denominator. And take these terms, which are, one is this, N plus P factorial. I take this term, N plus P factorial, P factorial and N factorial. These terms are taken. This become N plus P factorial by P factorial into N factorial. This N plus P factorial, this P factorial, this N factorial. This term be written as n plus p cp. n plus p cp. Okay. I take this term outside from sigma term because this is a constant term, this containing n plus p cp. Here we apply sigma only in the terms of I. I take these terms are common. N plus p cp, sigma I is equal to 0 to n. How many terms are remaining? One term is m factorial by I factorial into m minus I factorial into next term. Say this n factorial on numerator, this n factorial on numerator, this n plus p factorial we already taken, this term, this p factorial, this n factorial, these terms are already we taken. Remaining there are n factorial on numerator, denominator there is a factorial symbol, n plus I minus p factorial into p minus I factorial. Okay. We simplify these terms, which is equal to n plus p cp into sigma I is equal to 0 to n. See, this we written as mci, m factorial by I factorial into m minus I factorial. Similarly, this term we written as nc p minus I, p minus I. See, n factorial by p minus I factorial into this term n minus p minus I. Okay, n minus p minus I become n minus p plus I. This n plus p cp outside this terms, here we apply sigma for I is equal to 0 to n. Expand this term, either we expand this or using Vandermonde's identity, upper suffix always m plus n, lower suffix sum of upper suffix m plus n, sum of lower suffix p. In each term, if you expand this, mc0 into ncp plus mc1 into ncp minus 1 plus mc2 into ncp minus 2, etc. Last term mcn nc p minus n. In each term, sum of upper suffix is m plus n, sum of lower suffix is p. So we write this as n plus p cp into m plus n cp using Vandermonde's identity. Here we find the value of f of m n p. We directly substitute the value of f of m n p here. Then we reach the answer. Okay. Then what is g of mn? G of mn is equal to f of mnp. Here we find the value of f of mnp. F of mnp is n plus p cp into m plus n cp divided by n plus p cp. These two terms are directly cancelled. So g of mn is a simple function, that is m plus n, sorry, there is a sigma is equal to sigma p is equal to 0 to m plus n. 0 to m plus n. So I write sigma p is equal to 0 to m plus n, m plus n cp, which is equal to, we expand this m plus n, c0 plus m plus n, c1 plus etc. m plus n, cm plus n. It's expansion of 2 raised to m plus n. 2 raised to m plus n. So g of mn is what? G of mn is 2 raised to m plus n. This is g of mn. G of mn is 2 raised to m plus n. You know the result, m plus n c0. nc0 plus nc1 plus nc2 plus etc. ncn is 2 raised to n. Here upper suffix is m plus n. So I write 2 raised to m plus n. Then we check each options. See. First option. See the first option. G of mn equal to G of nm. It is very clear. G of mn is 2 raised to m plus n. What is G of nm? G of nm is 2 raised to n plus m. Both are equal. So first option is correct. Goes to second option. Second option, G of m comma n plus 1 is equal to what? 2 raised to m plus n plus 1. In the place of n plus 1, you write, so in the place of n, you write n plus 1. Just rearrange it. Just rearrange. 2 raised to n plus m plus 1. N and m are interchanged, which is equal to G of m plus 1 comma n. So second option is also correct. Then we check C and D. G of 2m comma 2n is equal to, in the place of m, 2m, and in the place of n, 2n. 2 raised to 2m plus 2n, which is equal to 2 raised to m plus n the whole square. A raised to m the whole raised to n. This becomes G of mn. So I write G of m comma n the whole square. So third option is incorrect. It is not true, but the fourth option is correct. G of 2m comma 2n is G of mn the whole square. So A, B, D. A, B, D. These three options are correct. Okay, thank you.